Hello, geometry. I apologize, I am gone today. So here we are. We're doing a video lesson instead. How fun. So today piggybacks off of yesterday. So yesterday we learned about all of the properties that make a parallelogram. Now today we are going to kind of do the backwards effect. We are given a shape that looks like a parallelogram, and then we have to say if it is one or not based on if it fits one of our properties, okay? So what you just need to remember is this little guy right here. You can prove that a quadrilateral is a parallelogram by showing that it satisfies one or any of the properties. So just one of them of a parallelogram. So if it works for one, it's a parallelogram. So for you today, I keep your hand on yesterday's notes, kind of flip back and forth, but here's just a little recap of our properties. We'll just run through them real quick one more time. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. Diagonals bisect each other. Consecutive angles are supplementary. And then that weird one pair of sides is parallel and congruent. And the key word there would be one. I might also want to point out that it always has to be both for these other ones. Both pairs of sides, not just one, okay? Again, just flip back and forth with your notes if you can't remember these, because that's all you're doing today, guys. Just looking to see if one of these works. So, it says, determine if the quadrilateral is a parallelogram. Justify your answer. So just remember, you justify. So if I look at this quadrilateral here, let's just notice this side's 5 centimeters, its opposite side's 5 centimeters. And same thing here, 12 centimeters and 12 centimeters. So we can definitely conclude that yes, this is a parallelogram because I'm running out of room. Since both pairs of opposite sides are congruent. Again, key thing there, kids, needs to be both pairs. And yes, you do have to write that out. I'm sorry, it's 10 words, but yes, that's what it wants you to do when you justify. See what this guy looks like. Surprise! Okay, let's look here. So, this is a really blurry picture, but that's okay. I have one pair of opposite angles congruent and one pair of opposite sides congruent. Now, is that enough, folks, to tell me that that quadrilateral is a parallelogram? Well, I would need both pairs of opposite angles and both pairs of opposite sides. So we are going to say a big old no. Not enough info. We need more. It could be, but we don't know for sure. We need more info. Okay, so the first 6 problems of your homework is just literally looking like this. We're going to give a parallelogram that looks like these, and then you decide yes or no, and then justify. Okay? Then we have, it says, on the coordinate plane, how would you use? So things just never go away in math, right? They always just come back kind of to haunt us. The distance formula. So if you don't remember that, jot this guy down where it says distance formula in your notes. But then we're also, save yourself a little bit of room because we have to write something in that box as well. How would I use the distance formula to help me show a quadrilateral is a parallelogram? So you're probably thinking, if I look at my properties, okay, kids, I'm going to go back, so if you're not done writing that down, pause it. But I'm going to go back here. Which one of these properties would use the distance formula to prove that it's a parallelogram? Opposite sides are parallel. No, parallel doesn't use the distance formula. Opposite sides are congruent. Hello. I can show distance. Distances are congruent. That's it. Let's just run through if there's anything else. Opposite angles. Angles does nothing with the distance formula. Diagonals bisect each other. Ooh, that could, nope, JK, not gonna work. Consecutive angles are supplementary angles, don't work with the distance formula, and opposite sides are parallel and congruent. So again, not congruent word. So if I want to use the distance formula to show lengths are congruent, that would show my opposite sides are congruent. So to show opposite sides are congruent. Bingo. So that's what you use the distance formula for. What about slope? Again, if you forgot what the slope formula is, jot it down. Take a second. Remember, M stands for slope. Subtract your y coordinates over your x coordinates. That's what your slope formula is. Okay, pause if you're not done copying that down, but I'm going to scoop back here a second. Okay, let's erase some of this. Okay, so slope. What would help me with some slope? Sides being, let's see, both pairs of opposite sides are parallel. That's a slopey thing. Congruent sides are congruent, not going to help me. Angles aren't going to help me. Diagonals bisect each other is not going to help me. Again, angles, no. One pair of sides are parallel. So key thing there, I can show lines are parallel based on their slopes. So that's how we would use it to show opposite sides are parallel. And again, what do you know about parallel lines? They have the same slope. All right, kiddies. Good work. We have one more, I believe, maybe. Can I scroll down? The midpoint. What's the midpoint formula? Add your x's, divide by 2. Add your y's, divide by 2, right? So it's the middle. I want the middle. So, again, I'm going to go back to my little properties page here. Okay. Something with a midpoint. If I want to show something with a midpoint, which one of these would be helpful? Well, let's do process of elimination if we have no idea. Parallel is slope. We've already done it. Sides are congruent. Distance formula. Both pairs of opposite angles are congruent. It has nothing to do with midpoint. Diagonals bisect each other. Bisect means they are cut in half. If I have a segment and it's being cut in half, kids, what is that green dot called? The midpoint. Okay, that's how we would know. So let's go back to our thing here. Let's see. So midpoint would help me show that diagonals would have the same midpoint. Because then they'd be bisecting each other. Maybe you want to write that down. Would be bisecting one another. I know I probably made that more complicated than it needed to be, but now you know. And now we're going to practice those, okay? Not all of them, just one of them. But let's try it. So it says graph the quadrilateral QRST with vertices blank, 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 and blank, and determine if the quadrilateral is a parallelogram. So obviously step one, take a moment and plot those 4 points for us, and I will join you right now. All right, Q, -1, 1, 2, 3. I'd probably label them just to keep yourself organized. That's really up to you. R31. S2, -3. And T, -2, -1. Perfect. Now I'm going to connect them And obviously, I mean, to the naked eye, yeah, it looks like it's a parallelogram, but we don't know for sure, right? On your homework, it will give you that you either have to use the distance formula, slope formula, or midpoint. But since it doesn't specify here, we can pick whatever we want. Okay? So, obviously the fastest one to check would just be our midpoint, slope, because we can easily count slope on a coordinate grid. So let's just do that one. So I'm going to use slope. So if I go back to my page here, if I want to use slope, I need to show that opposite sides are parallel, aka that they have the same slope. So let's jump back. So let's counter out, kids. So let's just start with QT. The slope, remember that's M of QT. Now I'm going over here. I'm going up 1, 2, 3, 4 over 1. So 4 over 1. Now let's check its counterpart, RS. So now the slope, M of RS. Here we go here. If I start at S, how many up do I go? 1, 2, 3, 4 over 1. So far, I have one pair of opposite sides that are parallel, which is good. But now I have to check the other pair. So let's start with the slope of, should we do, I don't know, QR? So slope of QR. So if I go from Q down to R, I'm going down 1, 2 over 1, 2, 3, 4. 2 over 4, which we all know, kids, really reduces to 1/2. Now let's check our final slope here of TS. So let's see how many I go down from T. 1, 2, and get to S. 1, 2, 3, 4. 2 over 4, again, that reduces to 1/2. So I see that they are parallel. And now I can decide, is this quadrilateral QRTS a parallelogram? And I hope you're thinking, yes, both pairs of opposite sides are parallel. So, yes, both pair of opposite sides are parallel. Good work, team. We did it. And then, of course, in geometry, always just throw in some algebra, so that's what we're going to end with today, all right? It says find the value of the variable so that each quadrilateral is a parallelogram. So here, we just kind of get to pick what we want to do. We're working with angles. Remember that opposite angles are congruent. So let's just start with a little bit easier one. I know that 56 is equal to 7x. 7x equals 56. Now what, kids? Well, I hope you're thinking you're dividing out. So x equals 8. Perfect. Now we have 4y plus 4 is equal to 5y minus 26. Get your variables to one side, so I'll have y minus 26 equals 4. Add my 26 over, so y equals 30. Sweet. Done. It's a parallelogram now. And one more here, talking about our sides. All right. Again, remember, kids, opposite sides are congruent. So here, this is blurry, I'm going to have 5x minus 2 equals 3x plus 4. Bring over my x's. Add over my 2. And x equals 3. So you got that's what you got. Okay. Then our last one here. 2y plus 6 is equal to 4y minus 9. 4y minus 9. 2y plus 6. Bring over my y's. There we go. Bring over my 9. 2y equals, what is that? 15? Why can't I math today? Oh, because that's a 5, not a 6. I thought that would look weird. That's a 5, guys. Sorry about that, folks. 5. Now we'll get a whole number. 5. So if I add 5 and 9, I actually get 14. There we go. Now if I divide out y equals 7, that looks better here. Right? Not like you can tell me if I'm wrong, but I think that's right. We're going to go with it. All right? Good work. So your homework, let's take a minute and peek at it. So pause the video if you want to jot that down. I'll try to talk quietly, but I'm going to go over some of the questions and what you have to do since I'm not here to help you. 2 seconds. Okay. So, I don't want to talk so loud. Okay. So guys, on these first ones right here, you're doing what we did in the first part of our notes. Decide if it is a quadrilateral or not, and make sure you justify. It's not just yes or no. You have to tell me why. Okay? That's the first part. Then we go to, okay. Yes, you have to do this proof. Helpful hint, prove triangles are congruent, and then you'll be able to tell me why this guy is an isosceles triangle. Okay, but here's your hint. Prove triangles are congruent. Okay. That's probably the hardest question on your homework. Then for here, you're just finding x and y on ones like 20. Remember, you have alternate interior angles that are congruent. Okay, and then you also have 2 variables here. So in one of your equations, you're going to have to get either x or y alone, then substitute back in. If you have no idea what that means, I hope someone in their class does help you. If not, save it for Monday, kids. We'll figure it out then. It's thinking. Okay, same thing there. On these ones, you have to use graph paper. So grab graph paper under or on the bookshelf up front, and then they're telling you which one you have to use. So if you're using slope formula, you're showing sides are parallel. If you're using distance formula, showing sides are congruent. Sometimes I might ask you for both. Okay, you decide. So make sure you do it the way they ask. And then I think we skip all the way to this back stuff, which is just a review. Hint to this one on you guys here, use graph paper. Graph it out, see what's happening. It is your friend, be a visual learner. Oops, a little too far. And these ones, you'll be fine. I have no doubt. Yeah. Okay. Have a super great weekend, kids. Enjoy the Super Bowl. Enjoy your time off. We'll see you Monday. And please be good for the sub. See you later.